In this video, I am discussing Bresenham's line drawing algorithm. Before starting with Bresenham's line drawing algorithm, I want to say general line drawing algorithm. So if you want to draw a line, we have to input the n coordinates. We have to give x1, y1, x2, y2, which are the end points of the line. So what the algorithm is doing is, it has to find out the intermediate points on the line path. Pixel xy values constrained to integer values. So during actual computation, the values may be floating point number, but before plotting, we have to round off that values. Because of this rounding off, lines which is producing may be jaggy. So it may producing jag lines. See this example. We want to draw a line from 3,2 to 9,6. 3,2 is the starting point and 9,2 is the ending point. So what we have to find here is, we have to find out all the intermediate points on that line path, which all pixel has to be turned on. So the equation of line is y is equal to mx plus p. Slope-intercept line equation is y is equal to mx plus p, where m is the slope of the line and p is the y-intercept. So if you know the endpoints, say x1, y1 and x2, y2, you can find out the slope by using the given this equation. M is equal to dy by dx. So dy is y2 minus y1 and dx is x2 minus x1. So difference in y value will be dy and difference in x value will be dx. So you can find out slope by using this formula. Now in Bresenham's line drawing algorithm, for slope less than 1, what we are doing is, we will plot the point xk, yk, then we have to find out the next point. What is the next point? For finding the next point, x coordinate will be incremented by 1. Then you have to find out what is the y value. Y may be either yk or yk plus 1, because the computed value is between yk and yk plus 1. So we can take only integer value. So we have to decide whether it should be yk or yk plus 1. So see this example. So here you can see in the first figure, we have plotted the first point 10, 11. 10, 11, so 10 is the pixel position and 11 is the scan line. So 10, 11 we have plotted. Now we have to find out the next values. So you can see the line is going up, x is incrementing and y also is incrementing. In the second figure, you see the line is coming down. So you can see we have plotted the point 50, 50. First point is 50, 50. Then x is incrementing 51, 52, 53. Whereas y is decrementing 50. Then it is coming downwards 15, 49, 48, etc. So we have to decide which point to be plotted next. So in this diagram, you see again we have plotted xk, yk. So I told you for slope less than 1, x will be incremented by 1 and y we have to find out whether it is yk. It can be either yk or yk plus 1. So see this figure. So here we can see the difference between, so y is the actual point. So y is coming in between yk and yk plus 1. Y is the actual point which is in between yk and yk plus 1. But we can take either yk or yk plus 1. Y is some floating point number, so we cannot take that. We have to take either yk or yk plus 1. So see, we are taking the difference between yk plus 1 and y as d2 and difference between y and yk as d1. So d1 is the difference between y and yk and d2 is the difference between yk plus 1 and y. So from this diagram, you can understand, so whichever point is closer to the line path, that has to be selected. So in this figure you see yk plus 1, the distance between y and yk plus 1 is smaller than y and yk. So which point we have to take? We have to take yk plus 1 because yk plus 1 is closer to line path. So for now, first we will discuss Bresenham's line drawing algorithm whose positive slope less than 1 with lines whose positive slope less than 1. So for drawing this line, start from the left endpoint. Let us plot the first point x0, y0. Each successive column, plot the pixel whose scan line y close value is closest to the line path. Assume pixel at xk, yk is plotted. So we are plotting the point. We are assuming that we have plotted the point xk, yk. So now what we have to do? We have to increment x by 1 unit. So x is incrementing by 1 unit. So xk plus 1, that is next x value will be xk plus 1. So we can say the next value will be the current x value plus 1, incrementing it by 1 unit. Then we have to choose the value of y. Y may be either yk or yk plus 1. Two possibilities are there. Either it may be yk or yk plus 1. So y coordinate at pixel column position xk plus 1 is calculated by. So we have seen that equation of line is equal to, line is y is equal to mx plus b. So what is the value of x here? Xk plus 1. Xk plus 1 is the value of x. So equation of the line is y is equal to m into xk plus 1 plus b. So this is the equation of that particular line. The y coordinate we can find out by using this equation, m into xk plus 1 plus b. So again, what is D1? D1 is the difference between y and yk. D1 is the difference between y and yk. So we can write D1 is equal to y minus yk. So what is y? Y already we found. Y is equal to m into xk plus 1 plus b minus yk. And what is D2? D2 is the difference between yk plus 1 and y. Okay, so d2 is the difference between yk plus 1 and y. So yk plus 1 minus y. So again, you know the value of y. We are substituting this value here. So we got d1 and d2. Okay. Now we are finding the difference between d1 and d2. d1 minus d2 is equal to, you see in the previous slide, what is d1 minus d2? d1 minus d2, this m into xk plus 1 is there here. Here also m into xk plus 1 is there. Thus minus minus. So plus. So that is 2m into xk plus 1. Then b minus minus b. So 2b minus yk minus 2yk minus 1. So that will be d1 minus d2. So we are finding d1 minus d2. So d1 minus d2 is equal to 2m into xk plus 1 minus 2yk plus 2b minus 1. So now, so I told you we are incrementing x by 1 unit. Why we have to decide whether to take yk or yk plus 1. Okay, so here we are going to find out a decision parameter. So this pk is the decision parameter to decide which point to take. So the equation of pk is equal to delta x into d1 minus d2. So d1 minus d2 already we know. So we are substituting this here. So when you are substituting this here, we'll get the equation like this, because some of the terms are constant. You can see here itself 2m. When you are removing the bracket, you are getting 2m. 2m is constant. Then xk is not constant, so that is why that value will come. And 2b minus 1, again that is constant. So here, that is why constant c is written here. So again I told you in this figure, so we are finding d1 and d2. So whichever is closer to the line path, that point will take. So if this distance is smaller, that is d1 is smaller, then yk is closer to the line path. If this distance is smaller, that is d2 is smaller, then yk plus 1 is closer to the line path. If d1 is less than d2, d1 is less than d2, yk is closer to the line path. d1 is less than d2 means this distance is smaller, so that is yk is closer to y or line. And d2 is less than d1, that is in this figure you see d2 is less than d1. So which point is closer? Yk plus 1 will be closer to the line path. So if the pixel at yk is closer to the line path than yk plus 1, that is d1 less than d2, then decision parameter will be negative. So pk will be negative. When this pk will be negative? When d1 is less than d2. So if pk is less than 0, or if pk is negative, or we can say if d1 is less than d2, then we will select yk. So now we have to find out the initial decision parameter. So pk is equal to 2 delta y xk minus 2 delta s yk plus c. So we have to find out the next decision parameter, pk plus 1. Decision parameter at xk plus 1 will be pk plus 1. So instead of k, we are substituting by k plus 1. K will be replaced with k plus 1. So you are getting this formula. So now next step is pk plus 1 minus pk. When you are substituting, when we are subtracting pk from pk plus 1, we will get this equation. 2 delta y into xk plus 1 minus xk minus 2 delta x into yk plus 1 minus yk. But you know, xk plus 1 is what? Xk plus 1. Current value of xk plus 1 is equal to previous value of x plus 1. Or we can say next value of x is whatever is the current value plus 1. So pk plus 1 is equal to pk plus, we are bringing this pk this side. So pk plus 2 delta y minus 2 delta x into yk plus 1 minus yk. And in the previous slide we have seen that if pk is less than 0, we'll take yk plus 1 is what? Yk. If pk is less than 0, yk is closer to the line path, and if pk is greater than 0, yk plus 1 is closer to the line path. Okay. Then to start with, we have to find out the initial decision parameter p0. p0 is equal to 2 delta y minus delta x. Okay, so this we are getting from this equation. Pk is equal to delta x into d1 minus d2. So delta x is equal to, we are substituting the value of d1 minus d2 here. So when you are solving this one, you will get p0 is equal to 2 delta y minus delta x. So now you see the algorithm. So algorithm, what was the first step? So you have to input the first endpoint, that is left endpoint x0, y0, the starting point x0, y0. So you have to plot the point. Then next step is you have to find out the initial decision parameter p0. p0, the equation is p0 is equal to 2 delta y minus delta x. So you got p0. At each xk along the line starting at k equals 0, perform the following test. What is the test? If pk less than 0, if decision parameter value is less than 0, the next point to plot is xk k plus 1. X anyway we are incrementing by 1, and y we have to decide. So if pk less than 0, y will be yk. And the new decision parameter pk plus 1 is equal to pk plus 2 delta y. Otherwise, that is if pk greater than or equal to 0, the next point to plot is xk plus 1, yk plus 1. X anyway incrementing by 1, but in here y also should be incremented by 1. In this case, pk plus 1 is equal to pk plus 2 delta y minus delta x. So see this example. Digitize the line with endpoints 2010 and 3018. That is, we have to draw a line from 2010 to 3018. So from this endpoints, we can find out the slope. How to find out the slope? Slope is equal to delta y by delta x. Delta y is the difference in y values. Delta x is difference in x values. So you got slope. Slope is equal to 8 by 10. So that is 0.8. And P0 is equal to 2 delta y minus delta x. This is equation 4, initial decision parameter. So you can see the value is 6. 2 into 8 minus 10. That is 6. So now you see, we are starting at 0th pixel. So you can see initial decision parameter you got 6. 6 is positive. So based on this value, we are deciding which value to be taken next. So here pk is positive. Pk is greater than 0. So if pk greater than 0, what to do? X should be incremented by 1 and y also should be incremented by 1. So what was the first point? 2010. So you have to increment x by 1 unit. So it will become 21. And y also should be incremented by 1. So y also will become 11. 10. It was 10. Now it will be 11. Now again you have to find out the initial decision parameter. So decision parameter formula is pk plus 1 is equal to pk plus 2 delta y minus 2 delta x. So when you are substituting this value there, so you are getting in the next step you will be getting decision parameter as 2. So you can see here again it is positive. So since it is positive, x should be incremented by 1, y should be incremented by 1. So x we are incrementing by 1, so 20 will become 21 and yk plus 1, that is y will be incremented by 1, 11 will become 12. So now again decision parameter is greater than 0, so you have to use this equation for finding the decision parameter. Pk plus 1 is equal to pk plus 2 delta y minus delta x. So you will get minus 2. Now you are getting minus 2. So minus 2 again, now you can see that pk is less than 0. If pk less than 0, what to do? X you have to increment by 1, y remains same, no change in y. So see here, x is incrementing by 1, y remains same. So x always we are seeing x is, we are incrementing by 1. In this case, if pk less than 0, y remains same. That is no change in y. Now again, here negative, the value is negative. So you can see here you have to use pk plus 1 is equal to pk plus 2 delta y. This formula you have to use now, because since pk is less than 0, you have to use this formula for finding the next decision parameter. So again here you can see 14, you are getting 14. So positive, and here since it is positive, x will be incremented by 1 and y also will be incremented by 1. This way it will be continuing until you are reaching the other endpoint. Okay, so this is regarding Bresenham's line drawing algorithm. Thank you.